Hello, everyone. This is now section 1.3. This section, I'm going to talk about two things. First, linear function, and second, quadratic function. All right. But before I start 1.3, I found one mistake on the last video about from this section 1.1 and 1.2. It was the last example, the very last example I did. The last example was about the transformations. So we need to find the graph of this, right? So that's what I did. The one mistake actually I found on that one was, well, this is the base function is this. So I said the cube root on the last video. Actually, it should be a square root, right? This is square root. I keep saying cube root, but yeah, this should be a square root. And another thing, when I transform this, so as we know that the graph of this is something like this. And when you transform this, this one plus 3 is inside the function. So we're going to move 3 units left. 1, 2, 3, right? And this -2 is outside the function. So I think on last video I said 2 units up, right? But it should be now here with this minus outside the function, it should be 2 units down, right? I think that's the mistake I did. In the last video I did 2 units up, but it should be 2 units down. All right, so yeah. Yeah, sorry about that. So this is the correct solution. All right. Now let's start this section. So this section again, like I said in the last video, the whole chapter 1 is kind of revision of the college algebra or any algebra class you took. So in this this section 1.3, the first thing we're going to look here is the slope intercept form, which is y is equals to mx plus b, where we said that this m is the slope and this b, we said this is y-intercept. Right, and the second one is point slope form, which is y minus y1 is equals to m times x minus x1. Again, here m is the slope. And the next one is the general form, or let me check in the book what exactly it is called in the book. Or it's called standard form. Yeah, I said general form. You can even say general form or standard form. So in the book it says standard form. Oops. Standard form. Which is ax plus bx is equals to c. So all of these a, b, and c are constant. Means these are some numbers. All right. We don't know the numbers. We're just going to say ABC for right now. All right. So, all right. So these are three form of the equation we need to know for this section. Okay. Now we said M is the slope, right? And slope we can also, well, there is a formula to find the slope. M, which is y2 minus y1 over x2 minus x1. Right, so basically the slope is when we have a line or a straight line, and if we know 2 points on this line, let's consider this x, y, and this also x, y. But since these two are two different points, so just to make it different, let's consider this as x1, y1, and this x2, y2. All right, so if we know 2 points on the line, then we can find the slope using this formula right here. Okay, now let's do some examples here now then. So we need to use all of these, or we are, yeah, let's say we are gonna use all of these the examples that I'm gonna show now. So, okay, so the first example, let's say, example. So the first one, let's say, just a simple example. Well, this equation is given and we need to find first slope, and the second one, find y-intercept. Okay, so the slope, we can say the slope easily when you compare this equation to slope-intercept form, the equation which is y is equals to mx plus b, right? So if we compare these two, so we have y here, y, x here, x, so that means m, our slope is 3, right? And y-intercept, which is b, is 2. Simple, right? Now let's do let's do another one. Let me another one. So let's say there is again a straight line, and now let's consider 2 points. So the first one, let's say it is 2,5. The second one is 5,7. All right, and then now here we need to find we need to find few things here. So first, let's say we want to find the slope. All right, so as I said here, if we know 2 points, then we can easily use this equation to find the slope, right? So here, if we consider these 2 points as x1, y1, x2, y2, then we can easily find the slope. So we know the slope formula is y2 minus y1 over x2 minus x1. So y2 is 7 minus y1 is 5 over x2 is let's do this. Let's say x2 is 4. So we don't, let's say this is 4. All right, so now we don't have to deal with the fraction. 7 minus 5 and x2 minus x1 is 4 minus 2. So we get 1, right? On the numerator you get 2, and the denominator we get 2, so 2 over 2 is 1. All right, so now the second one, we need to find point slope. Point slope form of the equation. So basically we need to find an equation in this form. So again, if you go back, the point slope form is y minus y1 is equals to m times x minus x1. All right, so we are trying to find the equation in that form. So whenever we are trying to find the equation, let's first write this, and then I can say that y minus y1 is equals to m times x minus x1. So whenever you're trying to find the equation, then we need to find the value of everything except y and x. So equation here with the linear equation, so we're considering linear equation, right? Because this is straight line. So with this straight line, if you're trying to find an equation of this straight line, then it should be in terms of y and x. So we accept the value of y and x. We need to find the value of everything else. All right. So that means y minus y1 is 5, m is 1, x minus x1 is 2. All right, so that's all you got to do here for the point slope form. All right. Now, if the problem asks you to now find a slope-intercept form, then as we know that the slope-intercept form is y is equals to mx plus b. So that means I need to change this equation to this form, y is equals to mx plus b form. So let me do it in the next page. So now to change the equation to that form, well, let's do it here. I think there should be enough space. So now I need to change this equation to this form, y is equals to mx plus b form. So to do that, it's easy. We have to basically just distribute this one to these two, which is not going to make any difference. So y minus 5 is equals to x minus 2, and then move this 5 to other side, or just 8, 5 on both sides. So then on left hand side, we just have y is equals to x plus 3, right? So this is now in this form, slope-intercept form, right? Because we have y is equals to mx plus b. So here m is 1, right? Okay, so the last one, we need to find standard form. Standard form is ax plus bx is equals to c. So here, since we found here y is equals to x plus 3, so here the standard form, we have y is equals to x plus 3, right? So the standard form is basically, when you see this, on one side you should have just a constant or just a number, and everything else should be on other side. Sorry, this is y, x plus by. Did I say the same thing here? Oh, I did a mistake here. It should be ax plus by. All right. Okay, anyway, on one side, there should be just the number and everything else should be on the other side. So that means I just have to move this x to other side or just subtract x on both sides. So then we get y minus x is equals to 3. And this is a standard form. So it's just the basic algebra. You just have to move terms here and there and just have to write the answer the problem is asking, right? Okay, now let's go to now to quadratic function. Okay, so the quadratic function here, we're going to look two different kinds of quadratic function. So the first one we're going to look here, we're going to say y is equal to ax squared plus bx plus c. Another one, we're going to look y is equal to a times x minus h squared plus k. All right, so we are going to consider two different kind of equations. Both of these are quadratic function. All right, now so here we have a on both sides, right? So this a says something. So if a is a positive number, or we can say if a is a positive number means we can say a is greater than 0. Right, so if a is greater than 0, our graph is always let's not do this. Since we know it's a parabola, so if a is greater than 0, then it's always going to be facing up or something like this. So that means like this, we're always going to have a minimum. So this point, this minimum point we call the vertex. So our vertex is always minimum if a is greater than 0. If a is less than 0, then the graph is going to be something like this. Of course, it's again a parabola. Now we're going to get a maximum vertex, or the vertex is maximum. Okay, so always this minimum or maximum point are our vertex. Okay, so then we can do an example. Let's say we have, let me do it here. Oops, just give me a moment to draw this thing. All right, so now let's say 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. And here, let's say 1, 2, 3. So let's say we have a graph, something like this. The graph doesn't look nice, right? Let's do this. Let's do this. Let me do it again. Anyway, just consider this as a parabola where it has a maximum vertex. So this is a vertex, and okay, so now here the vertex, if we are finding the vertex of this graph, then this maximum point is the vertex, so we can easily say that this vertex is 1 2 3 and 1 2 3 4. So the vertex is 3 4, right? And the x-intercept well, x-intercept means a graph where it intersect at x-axis, right? So here, since this is an x-axis, so this graph crosses the x-axis here and here. So that's why these two are x-axis, x-intercept points. So x-intercept point are, this one is 1 2 2, or we can even say 2 0, right? This point is 2 0, and second one is 1 2 3 4 5, so 5 0, right? And the y-intercept, so y-intercept is the point where it crosses at y-axis. So 1 2 3. So this graph crosses here on y-axis. So this point we say 0, 3. All right. So it's just that we have to read the graph and just answer the problem it is asking. The last one, you'll see the range. So the range means all the possible y values, right? So that means we have to consider, look at the y-axis. So y-axis, if you see this graph, the y-axis, it's from here, from this point, right, from this vertex point to all the way down. So this graph, y-axis, it starts from this point and it's going to go all the way down to infinity, right? Because this one is, if you see this arrow, this is going towards infinity. This is also going towards infinity. So the range, we're going to start from positive to negative. So 1 2 3 4. So we are considering this point as well. So if you're considering that point, we can have a square bracket from 4 to negative infinity, right? Because this is the negative side, this is a positive side. So from 4 to negative infinity. All right, clear? Because this is going towards negative infinity, and this is going towards positive infinity. Okay, that's one example. Now let's look at other example. Okay, let's do this one. Okay, now in this example, the graph was given and we need to find all of these. So we just have to read the graph and find all of these. Now, let's look at let me use a different color. So here, now the function is given. Now we need to find, first we need to find the vertex. Oops, I use the same color, red color anyway. So the vertex for these kind of equation, or if we have equation which is in this form, y is equals to ax squared plus bx plus c, then if we need to find the vertex of this kind of equation, then uh, there is a formula. So first h b minus b over 2a, and k is so k is the value. So let's I'm saying y. Let's just say f of x. All right. So instead of saying x, instead of saying y, let's say f of x. So the k value is f of h. So whatever value we get from here, we're going to take that value and put that value here to this x. I'll show you that later. So first, let's find the vertex. So now from this one, we get, we can say A, B, C. So the A is here on the front, A is 1, B is -10, and C is 16. Right, so that means first H is negative, because there's a negative here, and the value of B is also -10, so -10 over 2, A is just 1. So that means from here we get 10 over 2, which is 5. All right, now once we get the value of H, now to find the value of K, here I said f of H, right? So taking this function, K is, now instead of x, we're just going to replace this x by the value of H. All right, so that means 5 square minus 10 times 5 plus 16 is equals to 25 minus 50 plus 16. So 25 minus 50 is minus 25 plus 16. So this is going to give -9. So that means the vertex here, the vertex is always h comma k. So that means the vertex here we're going to get, we got the value of h and k, which is 5, 9. Right. Okay, so now the next one, now we're going to find x-intercept and y-intercept. So first, we need to find x-intercept. Let's find y-intercept, doesn't matter. So y-intercept. So to find the y-intercept, y-intercept, x value is always 0. You can take this like a formula, all right? At x-intercept, sorry, at y-intercept, x is always 0, and at x-intercept, y is 0. So you can take this as a formula. All right, so now here, now considering this one first, we can find the value of y-intercept. So let's go back. We have this equation, x squared minus 10x plus 16. F of x, or you can also write f of x as y or y as f of x, doesn't matter. Let's write y, x squared minus 10x plus 16, right? So now here, now to find a y-intercept, we're going to consider x 0. So y is equals to 0 squared minus 10 times 0 plus 16. So that means y is 16. Or so that means y-intercept point. So if you need to change this to a point form, so y-intercept point is 0, 16. Similarly here, now to find x-intercept, we're going to consider y0. So 0 is equals to x squared minus 10x plus 16, right? So now to solve this, there are lots of different ways. You can use quadratic formula. You can use, I don't know if you know AC method or not. Basically, you have to multiply this A and C. So 1 times 16, which gives 16, right? And then find the factors of 16, which gives 8. 16 times 1 is 16, 8 times 2 is 16. So we need to use one of these order pairs to modify this middle part. So the first and the last term is going to stay the same. So instead of writing negative 10x using these one of the pairs, we can change this negative 10x to, let's say if I use 8 and 2, well, I can use 8 and 2 because 8 minus 2 will be minus 10x, right? So that means I can use negative 8x, negative 2x, because negative 8x and negative 2x is negative 10x, right? Now I can split this into two parts. So from these first two, I can factor out x. So this will give x minus 8. From these two, I can factor out because I have negative 2 here, I have positive 16 here, so I need to consider negative as well. So negative 2 and negative 8x. X minus negative 8, sorry, yeah, x minus negative 8. Now again, from these two terms, I can factor out this whole thing, x minus 8. So the remaining terms are x minus 2. All right, so this way we get either x minus 8 is equals to 0 or x minus 2 is equals to 0. So x is equals to 8, positive 8, and here x is equals to positive 2. So we got two values of x, so that means we have two x-intercept, which the first one is if I change this to a point form, 8 minus 0, and also if I change this to a point form, 8, 0 and 2, 0. Okay, so we got both y-intercept, x-intercept. All right. And also here, we can find, we can say, let's go back. Here, after we get the value of vertex, we can also get the maximum or minimum. So the maximum and minimum depends on, like I said, maximum and minimum depends on the value of A. If A is positive, the graph shape of the graph is like this, right? If A is positive. If A is negative, it's like this. So that means here we have A positive, so we're gonna get minimum value, right? So the minimum value is always equals to whatever the K value is. All right, so here the minimum value we get here. Min is equals to the K value we got is 9. All right, so this is the vertex. This is the minimum value is equals to 9. All right. Okay, so here we got, so if we have a graph or if you have a function on this form, ax squared plus bx plus c, then we use this equation. We use this equation to find the vertex and everything here. Now, let's say if we have another equation, another quadratic equation in different form, in this form, let's consider f of x. F of x is equals to x minus 2 square plus 9. So this is this form, right? A times x minus 8 square. So here, Now, to find the vertex first, as we said, the vertex is always h comma k, right? So to find the vertex, all we have to do here is just compare these two. Here, a is 1, x is x, and there is a minus minus. So h, just the value of just h is 2. And the value of k is, there is a plus plus, so the value of k is 9. So that means the vertex here, we can say vertex is 2, 9, right? And similarly, we can find y-intercept, or we can find max min. So here, since the a is positive, right? So if a is positive, then we get minimum, which is equals to always k value 9. Okay. All right. So now to find y-intercept, we consider x is equals to 0. So from this, we consider x. We can also change this f of x to y. So y is equals to this is going to be 0. So 0 minus 2 square plus 9 is equals to 0 minus 2, or negative 2 square is 4 plus 9, or just 13. So that means the y-intercept point is 0, 13. Right? Similarly, now to find x-intercept, we're going to say y is equals to 0. So if I say y is equals to 0, or f of x is equals to 0, we're going to get this is equals to 0, because if I write 0 here or here, if I write 0 here or here, it doesn't make difference. Still, this is equals to 0. Now, now we're trying to find the value of x, right? So the simple way here we can do is, okay, so here, I should have actually said this minus. That way we don't have to consider, the imaginary thing. So if I say that is minus, then we're going to change this to minus as well. It doesn't make difference. But I'm just trying to not make this imaginary number, so that's why. 4 minus 9 is negative 5. So this way we get this 0, negative 5, right? And also here we get all of this negative 9 here. This negative 9, so minimum is negative 9. All right, so the reason I don't want here the positive is I will get the imaginary number. So all right, so now let's consider this way. So now now to find the value of this, well, there is a formula, or there is the idea where we can say, let's say if we have a square, m squared is equals to a, then just the value of m will be plus minus square root of a. All right, so we need to consider this plus minus both condition. All right, so so then here we can change this equation to this form, right? Because if I move this 9 to other side, then we get on left hand side we get x minus 2 square is equals to positive 9, right? Now on one side we have a square term, right? This whole thing we can consider the square term like this, which is now in this form. So So now using this idea on left hand side, this whole thing that is inside the square x minus 2 is equals to plus minus square root of 9 x minus 2 is equals to plus minus 3. So from here we get two conditions or two answers. The first one is with the plus and second one with the minus. The first one, x minus 2 is equals to positive 3, so x is equals to 5, and second one is x minus 2 is equals to negative 3, so x is equals to negative 1. So here now if I change this to point form, then I get 5 minus 0, and this one I get negative 1 comma 0. Right, so these two are x-intercept point, and this is y-intercept point, right? Okay, the last one, there is one more example. The last one, now last one is slightly different. Last one is about solving x squared plus x minus 6 is less than equals to 0. So here we are solving these kind of quadratic equation with inequality. All right, so now to solve a quadratic equation with inequality, I'm pretty sure that you guys have done this in college algebra. So the idea here is first, let's just change this to equal sign just for right now, just to solve for x. So to solve for x, we get x squared. So a times c is a times 6 times 1 is 0. So 6 times 1 is 6. 3 times 2 is 6. So it looks like I can use 3 and 2 for this middle part because we have just x first and the last term is going to stay the same. So using 3 and 2, I can say positive 3x minus 2x. All right, so from now, if I split this into two parts, then I get from the first part, I get, I can factor out x. So x plus 3. From these two, I can factor out negative 2. So x plus 3 is equals to 0. So again, from these two, I can factor out x plus 3. And the remaining terms are x minus 2. So from here, we get x is equals to negative 3 and x is equals to positive 2. All right, so here, since we have inequality, right, the original equation has inequality, we just change that to equal sign just to get this x values. But since we have inequality, so our x value cannot be just these 2 points. It has to be some reason. So to get that reason, well, since we get x is equals to negative 3, so let's plot that here on the line, negative 3 and positive 2. So it has to be one of either, it has to be either this reason or it has to be this reason in between or this reason. So to get that thing, the idea here is very simple idea. Let's say if we have a function, quadratic function less than equals to 0, if you have something like this, then our solution should always be this middle reason. All right, and if we have f of x greater than equals to 0, then our solution should be always these side regions. So this or this. the left side and the right side both. All right, so here, so since we have a quadratic function less than equals to 0, so it has to be this reason. So this reason is true, and this reason is false, and this reason is false. So now, since we have here a strictly equal, then, right, because we were considering the equal to as well, right, less than equals to. So since because of this equals to, we need to consider this in point as well. So we can have closed circle here, closed circle here. Now the interval notation in interval notation is from -3 to 2, and on both sides, since we're considering these 2 points, so close bracket, close bracket. So this will close bracket. Yes, all right. If we had here greater than, for example, we had this greater than, then everything will be same. It's just that now this side will be true, and the middle. So this side will be true. This side will be true. The middle reason will be false. So now, to write this in interval notation, we just have to consider from -infinity to -3 and 2 to infinity. And on the infinity side, it's always parenthesis. It's never a bracket. It's always parenthesis. And again, since we are including -3, so square bracket. Here we were including 2. That's why square bracket, and here always parenthesis. And in the middle, you always write U, which means or. Okay. Yeah, I think the video has been slightly too long. But anyway, this is it for 6 and 1.3. All right, thank you.